It was 1660. Robert Hooke, a contemporary of Sir Isaac Newton, was sitting in his lab. All of a sudden, he noticed a spring. He wanted to understand the behavior of a spring. So he stretched it, he compressed it, he let it go. And he realized that force has something to do with the stretch. And he hypothesized F is proportional to x. X is the displacement of the spring. And then he wanted to understand how much work he has to do to stretch it. And then he realized that the potential energy stored in the spring is proportional to x squared, which is also the square of the displacement. Now, after a series of experiments, he ended up realize F is actually equal to kx. K is the Hooke's constant, or steepness of a spring, and Pe is actually half kx squared, and again k is the steepness of a spring. For example, so this spring now has a bigger k. This spring has a bigger k than the spring on the other side. Now let's get started with this lab. Our goal is to find the mass of the orange, and here's how you can find it. I'm going to put the ruler at the relaxed position of the spring and then put the mass, and I'm going to try to understand or try to read the displacement. And if I read the displacement, I will see is displaced